For the past week or so, I've been writing a Python program that I've named Vortex Crypto, Vortex being my software brand of sorts. It's a GUI made to be able to access cryptography, mainly encryption, as well as a few other useful functions. The GUI was built using the Kinter Python library and PyCryptodome, an improved fork of PyCrypto. Right now, the project is technically not open source, but it will be available as soon as I post it on my GitHub. The link to the repository will be added to the description of this video. I figured that because the interface might be rather confusing for first-time users, I thought I'd take the time to go over how to properly use all of the features available. So, with that being said, let's get into it. I will preface this by saying that this program was written with Windows in mind, however, because it uses Kinter, a Python GUI library, it should work on Linux, should you have the proper dependencies installed. Looking at the GitHub repository, there should be a provided SHA-512 hash of the executable file, so if you really felt the need to, you could actually verify the integrity of your download to make sure that you have the right file and that it hasn't been tampered with. You can do this on Windows by opening the terminal and using the command shown on screen. This will calculate a digest in SHA-512 of your executable, and if it matches the one posted on the GitHub repository, you can confirm that you have the right file. At this point, you should already have extracted the zip archive to a folder. In that folder, you'll see a document named Important Use. This is a document containing both the terms of use, ways you can troubleshoot if you have issues, and resources that help to explain the overall security of the cryptographic algorithms that Vortex Crypto uses. Once you've read over the information in that file, we can take a look at the program itself. Opening the program window should only take just a few moments. Once the interface comes up, we can see the options here that we have to work with. At this time, Vortex Crypto's primary function is encryption. The encryption algorithm used by Vortex Crypto is Advanced Encryption Standard, or AES for short. Originally known as Rijndael, named after the two cryptographers who designed the cipher, AES is a symmetric encryption algorithm, meaning that the same key is used to both encrypt and decrypt data. This is in contrast to asymmetric encryption, often referred to as public key cryptography, but we'll get to that some other time. For this video, I will refrain from explaining all of the complex mathematics and statistics behind what makes AES such a secure algorithm, but you can find all of that information in the aforementioned Important Use file. Looking at the program interface, we can split the view into two sections. The top section is for handling encryption, and the bottom is for additional purposes, such as changing the GUI theme/color scheme. We'll start with the top section first. There's an input box and an output box. To simplify things as much as possible, for now, in the input data box, you're either going to be putting data that you want to encrypt, or data that has already been encrypted. Then, you'll be entering a key for said data, encrypting or decrypting it, and the output will be printed in the output data box. There are a few things to know about AES, however, before you use it. You will likely find that many sources state that algorithms like AES 256 would take the lifetime of the universe to be able to crack, even with foreseeable technology. There is some truth in that, but let's cover exactly why that is. Rijndael, or AES, is a block cipher with a fixed block size of 128 bits, meaning that the cipher takes and encrypts a block of 128 bits of data. If the input data does not meet this 128-bit requirement, the data is padded in order to reach it. However, it has a variable, yet fixed, key length. What do I mean by that? AES encryption keys can have a length of either 16, 24, or 32 bytes/characters. These key lengths equate to AES 128, AES 192, and AES 256, respectively. The length of the key that you input must be one of these lengths exactly, otherwise it will not work. Another factor that determines the security of the encryption process is, as I outlined in the Important Use document, the cipher mode. The cipher mode essentially dictates the specific way that the cipher is going to encrypt the input data. AES has quite a few different modes that can be used, but the mode that Vortex Crypto uses is Cipher Block Chaining, or CBC mode. Like I said earlier, there's a lot of math involved with the way AES encrypts data, but I'll just give a simple explanation of the way CBC mode works. Cipher block chaining essentially does exactly what the name states. Data is passed through a chain of cipher blocks which each encrypt the input data in their own way. This mode in particular, along with a few others, uses what is called an initialization vector, seen here. The initialization vector, or IV, can be seen as what is basically a seed that randomizes the digest of the data. When the input data is passed through the blockchain, the vector is injected alongside it. This effectively makes it so that the resulting ciphertext cannot be cryptanalyzed via pattern searching. Unlike the key, this 16-byte initialization vector does not have to be a secret, as long as it is not known before the data has been encrypted. It should be noted that, ideally, the vector is generated randomly, in order for it to be properly secure. So, taking all of that into account, now we can use Vortex Crypto to properly take advantage of this encryption algorithm. Looking at the interface once again, let's say we want to encrypt some data. For this example, we'll just do a few words. We'll put in our plaintext data in the input data box, and we'll enter our encryption key. For my password, I chose ABCDEFG. Very secure, of course. If you remember what I said earlier about key length when it comes to AES, it is variable but fixed. The key that I've input is only 7 characters long. If we want to use it, we need to extend it to be either 16, 24, or 32 characters long. I could just make the password longer, including more words or characters if I wanted, but instead what I'm going to do is I'll use the hash plus trim button. If you remember what I said about hash functions earlier, if you hash a piece of data, you will get the same resulting digest every single time. What this button does is it hashes the key that you've put in, and it trims it according to what AES key size you currently have set. My hash key gets trimmed to 32 characters, because my AES option in the dropdown is set to AES 256. Let's say you wanted to trim the key to 24 characters. All you have to do is set the option to AES 192, and as you might guess, for 16 characters, set the option in the dropdown to AES 128. Keep in mind, this method theoretically is secure. However, if you don't trust in this method that much, you can always just enter your password without hashing it, as long as it matches one of the 3 lengths. Since we're encrypting data, there's no need to touch the initialization vector field. All that's left to do now is click the encrypt button. Now, if you look in the IV box, you can see that our vector was randomly generated automatically for us, along with the ciphertext of our data in the box below. Technically, that's all you need to do. You've encrypted your data, you know the key, you have the vector, and now you can do whatever you want with it. Anyone with the key and the vector can decrypt it. Now, if you so chose, you could store the vector and the ciphertext in a file somewhere on your own accord, but Vortex Crypto actually makes this very easy, and you don't even need to manage the vector at all. If you look over, you'll see an open and a save option. In my case, since I might want to send my encrypted data to another person, or maybe store it for later use, I'm going to come over here and click save. This will allow you to save both the vector and the ciphertext in one file. The file gets saved as a .vtxc file, short for Vortex Cipher file, which is really no different from an ordinary TXT file. I decided to give it a unique extension in order to better distinguish it from other documents. Now, let's say I want to decrypt this later on, or maybe I want to send my encrypted information to a friend who also has Vortex Crypto. All you have to do is go to Open, find the Vortex Cipher file that you want to load, and both the ciphertext and its vector gets printed into their boxes automatically. Now, all I have to do is put in my secret key, hash it because I hashed this password, and then click the decrypt button. And just like that, the plaintext data is printed into the output box. It's really that simple, but as I said near the beginning of this video, this program can actually do a bit more than that. Moving on down to the bottom section of the interface, there's 2 utility options that you can use, should you want to. Just put in the length you want as a number, and click random string to generate a random string with that many characters, or random bytes to randomly generate that many bytes. We also have the option to change the theme/color layout of the program. There's a number of preset themes that I've made, but if you wanted, you can also enter your own colors, either as a hex code or as the actual word. I believe the color names are web format, so they should all be lowercase. And if it's a 2-word color, just join them together. For now, that's pretty much all there is to it. In future updates, I plan to add the things you see on screen here, and maybe some worthwhile suggestions if anyone has any. Other than that, now you know how to use Vortex Crypto. Until next time, thank you for watching.